Dear students, how are you? Today we're going to resume with Software Design Architecture module, Software Metrics. What is software metrics? From the title itself, can you guess the meaning of metrics? We have heights, which we can measure using meters or centimeters. We can measure our weight by using the weight scale, measuring in terms of kilograms. How about software? Can we measure software? What is software metrics? So in this course, we're going to look at different types of software metrics. And in particular, we are going to look at software metrics for object-oriented design. But let us first define software metrics. Software metric is defined as a quantitative measure of a degree to which a software, its system, the components, or the process, in possessing a given attribute. There are many attributes depending on the type of metrics. In this course, we are going to look specifically at coupling attribute as well as cohesion attribute. Before going deep into object-oriented design attributes, let us look at different metrics used in software. Firstly, there are project-based metrics and design-based metrics. Project-based metrics are measures of the continuity of a process in a software project development. In this course, we are not dealing with project-based metrics. Instead, we are looking at design-based metrics. Design-based metrics are quantitative measure of the attributes of the design. There are two general categories here: traditional design-based metrics and object-oriented design-based metrics. For our understanding, let's look at some traditional design-based metrics. These are the popular traditional design-based metrics. Sources of lines of code, which determine the size of the program. Comment percentage CP, which help us to measure readability or maintainability of the code. McCabe cyclomatic complexity, which help us to determine stability of the program. The least complex code would be a linear McCabe cyclomatic complexity. The more loops there are, the more complex the code is, the less stable the program becomes. The other popular metrics, traditional metrics, would be for the performance, known as Big O. The Big O notation measures the performance of a program in completing the task in terms of time. This would be constant, which is the ideal situation, the desired log time, linear time, and the one that we want to avoid in algorithm design, exponential time. Now we are done with the traditional design attributes, design metrics, and now we are moving on to the cream of this lecture, which is object-oriented design metrics. If you remember the definition of metrics, it is about the quantitative measure of a degree to which a software possesses of a given attribute. In object-oriented design, the attributes that we'll be looking at will be cohesion and coupling. What are these attributes? Coupling measures the interdependency between modules in a software structure. In object-oriented design, we have been looking at some class diagrams. Class diagrams are made up of classes which are interconnected with one another. So the way we organize these classes, these components, will affect the coupling, and that is what we mean by interdependency. High coupling is not desirable. High coupling, also known as tight coupling, is not desirable because if there's any change to one of the two interconnected classes, the change may impact changes to another class. This is not good for maintainability. We would prefer loose coupling because it promotes maintainability. The other attributes that we discuss a lot is cohesion. Cohesion is about if a class is doing a very specific task. This can be defined as having a set of methods which is very, very well defined, well focused for a specific task. A highly cohesive class has a set of methods which are highly relevant to each other to do a very well defined specific task. This promotes usability of the class. There are two types of cohesion. Cohesion of methods, which is the one that I have been talking about earlier. And the second type of cohesion is cohesion of classes. For cohesion of class, a well-designed cohesive class should represent one single well-defined entity in the problem domain. In the domain of university course registration, we have classes like student, courses, lecture, department. These nouns are the entities which we should define as individual classes. In another domain, such as shipping, routes, transport type, slot, these would be the classes that we would define for that domain. We should not define a class that is ambiguous. A class that is ambiguous, for example, instead of defining student class for course registration system, we define a class called people. That is too ambiguous. That class, people, is lacking cohesion. Moving on. So, remember, the metrics that we are focusing in this lecture are the metrics for object-oriented design. We are not talking about software project metrics. We are not talking about design, traditional design metrics. We are talking about object-oriented design metrics. And object-oriented design metrics in this lecture is focusing on maintainability attributes, which are coupling and cohesion. We want loose coupling and high cohesion for the methods, high cohesion for the class design. So there are a number of metrics used in object-oriented design. The first major attempt was done by Schidember and Kammerer in 1991, who proposed the following 6 metrics. WMC, which stands for weighted method per class. CBO, coupling between object. DIT, depth of inheritance tree. NOC, number of children. RFC, response for class. LCOM, lack of cohesion of methods. Now, do not feel frustrated by the use of these acronyms. As we visit each one, you will familiarize yourself with these metrics by looking at these examples. By trying out the examples, you will be able to recall the metrics and be able to use them to solve problems. Let us look at the first metric. Let's look at this example. This is a class diagram of a library loan system. We'll be using this class diagram for the discussion of our metrics. The root of this class diagram is holding, which has subclasses loan and copy item. Loan are those assets from the library that students or lecturers or visitors can borrow, that can be taken out for a period of time. Copy item, on the other hand, are things, printed materials, tapes, optical drives, that you can only view in the library. However, you can make copy of these items by using the photocopier machines available. Now, let's look at the loan class on the left. Under the loan class, we have printed material and recorded material. Printed material would be publications, such as books, magazines, which you can borrow. Magazines, for example, you can have desk loan. You borrow it from the shelf by registering your loan for a very short period of time. You can have the normal short loan, maybe 1 to 2 weeks, or you can go for long-term loan of the books. In the other class, the sibling is recorded material. Recorded material, as the name suggests, are not printed materials. Example of recorded materials could be tapes, could be optical drives. This would be recorded materials. Now, on the other side, the copy item, we have a musical sheet as well as journal articles. So, what is weighted method per class? Weighted method per class is usually determined by counting the number of unique methods inside that particular class. So each method is usually given the weight 1. That will allow us to simply count the methods for each class. But it's not necessary all the time given weight 1. Let us look at one example. Let us look at WMC for holding. Now, in the class, the first section is the name of the class, the second section is the attributes, and the third section are the methods available in that class. How many available methods in here? Let's count. 1, 2, 3, 4. There are 4 methods here. Suppose each method is given weight 1. What is the total weight? 4, of course. Therefore, the WMC, the weighted method per class of holding, would be 4. Now let us look at loan. How many unit methods do we have there? 2, right? So WMC for loan is 2. And WMC for copy item will be 4. So that's how you determine weighted method per class for a class. If the weight is 1, you simply count the method. So we are done with the first section of this lecture of 15 minutes. Please, after this, look at the second section of this lecture. Thank you.